Good afternoon. I hope I don't give you indigestion. I see you had a nice lunch, some of you. So everything's up, right? Am I good? All right. So we're going to talk about cold-in-place recycling. And just to let you know a little bit of the history about cold-in-place, you'd probably think, well, where did all this come from? The first project ever completed in Pennsylvania was in Luzerne County. All right, on a roadway, and it was constructed by E.J. Brenneman from Reading, Pennsylvania. At the same time, a project was also done in Allegheny County. Trumbull Corporation recycled that. So that's a little bit of history of where recycling came. And as Andy said, it was one of those processes PennDOT did, and they put it on that shelf up in the DOT building in Harrisburg and kind of forgot about it for a little while. So as far as the pavement curve goes, we're all the way down the bottom. I'm going to talk to you today about cold in place and full depth. We're in that poor category, you know, where the roadway has completely failed to where it's got to either be reconstructed or recycled or full depth reclamation. That's a typical view of the asphalt recycling train. It's an inline process, so basically you can keep a roadway open while you're reconstructing the roadway. So what is cold in place, all right? It's the recycling of a deteriorated asphalt pavement material that's reached the end of its serviceable life. The life's gone, it's oxidized, it's patched, it's potholed, it's cracked. All those things that you would want to correct, and how can we correct them in one swift move? In some cases, the underlying aggregate may be incorporated into the recycled mix as we're recycling. Dual additives. We use a dual additive today. Used to be that we could only use an emulsified asphalt, but we now can add aggregates to it. We can add Portland cement, and there are other additives we can use. I like to see an emulsified asphalt with 1% Portland cement, and we'll talk about that a little later. Typical depths, 3 to 5 inches compacted. And the milling machine down cuts. You can't take a regular milling machine, which is an upcut machine, and do cold in place. Reason being is if that's your pavement and an upcut machine comes under a corrugated or alligated section, it breaks it off in larger chunks and they segregate, they get into the mix and play havoc with the mixes. So a downcut machine is cutting downhill. So as the machine moves forward, you're cutting down at the pavement and you're chipping it into a particle size. Faster the machine goes, the larger the particle size. So we have to judge whether we're going to do 22 feet a minute or 30 feet a minute, depending on the gradation we are creating behind. We try to make a 2-inch gradation minus. So what the asphalt pavements eventually depend, as you know, cracks, raveling, pothole, poor ride, cross sections. The roadways are getting cold in the wintertime and very hot in the summertime. So you're going to have all kinds of cracking going on, potholes. This is a typical type of roadway that we would recycle, patch on top of patch. Here's a good roadway for recycling. You see the center has gone already, so the joint at the center is broken apart. It's been patched several times. You've got, looks like, some widening going on at the edges of the road. You've got those cracks all over the place. Here we've got a lot of raveling going on. We've got widened areas where the joint of the old pavement and the widened area have broken apart. Another typical section here, corrugation, you got patch on top of patch. And the photographs to the right is where you've got a very soft asphalt has been applied and you've got those rumble strips being created. Now, when we look at mill and fill, when you're looking at this particular roadway, so the one section has already been milled off and you see the corrugation on the bottom, and of course all the cracks that were there have been filled in by the fines from the milling operation. Now, do we ever go in and scrub those cracks open and then crack seal them? No, we go in and we pave right on top of what we see there. You'll see the crack on the center there. that's coming across the roadway, and you can follow that crack all the way through up to the corrugated area. Another spot here. What I'm trying to say is, why would you just mill that off if the pavement below that is exactly the same as what you just milled off? It doesn't make sense, does it? So what we're doing here, if you look at these core samples here, so on the left we have an area where it's cracked from the top all the way down, working our way across. Let's say we mill off 2 inches. Well, our crack pattern's still there. And now we put a new overlay on top. Well, how long does it take before that gets cracked through again? On the third sample there, we're going to put the overlay right on top of what the old surface was, and the cracks are still there. But if we take all of that material from the left core and recycle it, we eliminate all the cracks, all the potholes. They can't come back, they're gone. And then we place our overlay on top. So a recycled mix needs to have an overlay placed on top. What that overlay is depends on the ADT of the roadway, excuse me, and other situations like that. So here's a typical case. You've got a roadway, I'm just going to say for the sake of a rotten roadway, it's gone. It's completely, this is old Route 6, and it's completely shot. And there's the recycled pavement right next to it where we picked up that material and turned it into a new base before compaction. Here's another typical roadway. This roadway was scheduled to be closed down by the supervisors of a municipality because of the bad ride it had and the potholes, and they couldn't seem to come up with a solution to fix it. If you look to the right photo, you can see where one lane has been recycled. All of that rotten roadway has completely gone. And there we have a look at the cross section after, and that's just the recycle. That's without any kind of a wearing surface being placed. So what are the benefits? The roadway remains open during construction. The only time we would close the road down for a moment is when we're fueling the equipment or we have to put water into the milling machine to help with the downcut operation. It conserves the natural resources. It's green technology. You're going to recycle 100% of the roadway, not just a small area. Reduces the impact on adjacent roadways. You're not milling off that material, hauling it away, and then bringing in a new base course. It reduces the cost over reconstruction. It's only a fraction of that, probably about 50%. Little materials exported from the site. We do, when there's curbs involved, have to export some material away from the site. Reuses existing materials. We reprofile the road. Restores curb reveal. It's environmentally friendly. Construction time is halved. A typical construction time that would take a week, it would take this machine probably 2 days. No drop-offs or open cuts for vehicles to drive into. You know how the general public are. Problems encountered in the preparation for a CR. Any damaged cross pipes should be replaced before a recycling operation. Drainage and water problems should be addressed. I always try to look at a roadway while it's raining. I want to see what condition, what's holding water, what do we need to do to reshape the roadway. Vegetation growth, we need to get that removed from the edge of the road. Sometimes that's over the road by a foot. We need to find out where the edges of the road are so we can recycle right up. So it may be something that the municipality or the agency needs to do. Shoulders or pavement widening should take place. Some municipalities like to widen the road a couple of feet. Some of them are out of, they may only be 16 feet wide and they want to go out to 24. Well, we don't do all that before time. Any underground utilities, if we're working within a city or a borough lines, there may be new gas lines, water lines, sanitary sewers that need to be replaced. Do all of that before you recycle. And any overhead obstructions we need to get moved. So what would prohibit a cold in place? Well, I hate to tell you this, that roadway right there, that looks the same as when I took that picture a few years ago. I drove it purposely to make sure I was correct that this roadway has never seen an ounce of crack seal, not an ounce. I've been back there over the last 25 years with the municipality 3 times to tell them what to do with the road. The first time I told them, hey, crack seal it and maybe put a chip seal on top of it. The second time I told them to cold in place recycle it. And the third time I went back, I said, you got to reconstruct that or do full depth reclamation. I'm not sure when the next time I'll go back there, but there may not be any road left at all. Yeah, that's an actual photo. And that's what it looks like today. It's a shame it's in our district. And there's another couple of roads. We wouldn't do these. They're not good candidates for cold in place. They've gone too far. What other restrictions? Well, a lot of times we had to do a bridge that has a weight limit on it. We're either got to back up to the bridge and pull out and then mobilize around to the other side and do the other side of the road. A lot of railroads in Pennsylvania, a lot of tunnels, and in the same way we've got to back up to them and pull them out. Cross pipes. So replacing the cross pipes, important, but do them the year before, give them a chance to settle. All right. Otherwise, we come in, we recycle the road, put an overlay on, and the next thing you've got is a settlement where the cross pipe was and the aggregates have settled down. So get them done a year prior. And then when you recycle over and take out any imperfections in that cross trench. If you don't, you have a situation like this. Brand new road, cross pipe failed after it was recycled and overlaid, and now you've got to come in and put a patch in the road when you put your new cross pipe in. Situations with springs. Take care of the springs. If there's a spring in the road, bleed it off. Get that water out of there. So important, but a lot of times never a condition to do before you go in and reconstruct. In this case, there's a wheel rut. Where does the water flow? It flows down the wheel rut. It gets to a point behind those evergreen trees. It makes a right turn across the road and onto somebody else's property. You know, you might think, that's okay. But you know what? There's a catch basin right there. But the water never gets to the catch basin. So when you recycle a road, reprofile it, you make sure that that water gets, before it crosses the road, into that catch basin and away from the project. We all know what water does to a road. Let's get rid of it. Okay, so the process itself is you're going to core the roadway. We need to find out what types of material, how thick the materials are. So we need to take core samples, and we need to keep that material because if that road turns into a project, we need to have that material to make a mixed design from. PennDOT approved mixed design, obviously. Any widening to take place prior to CRR. If the roadway is curbed, check the height of the curb. What curb reveal do we need at the end of the project? Remembering that we're going to be putting maybe 1.5 inches of 9.5 millimeter on as the wearing surface. The recycling is a base course. The CIR train resizes and mixes in place the materials and then takes them and places them via a 2-stage conveyor system into a bituminous paver. And then we do whatever the cross slope is, change the cross slope sometimes within inches, not feet. We can't change drastically, but we can change within a few inches the cross slope itself, taking it to a 2 or a 3% cross slope. Compaction-wise, 12-ton vibratory steel wheel rollers, 22 to 25-ton pneumatic tile rod. It's not a chip seal roller. It's a roller built especially for cold in place. It's 25 ton. Placement of a suitable wearing surface, whether that's a chip seal or a hot mix asphalt or an ultra thin or whatever it is, the agency needs to establish that and put that into the bid specs. Core sampling, as I said, it's essential. You know, most of the cracks in a roadway go, as you can see on the left here, the crack starts at that top and goes all the way through the core. Here you can see, looking down through this roadway, you can see how many times you can see the paint there. There's 3 different layers of asphalt there. In this case, well, I'm not sure, there are 6 layers of asphalt. So if you said each layer lasted 8 years, that's 48 years of asphalt. At what point did you realize you needed to do something else with the road besides sticking another asphalt on top of it. That there really is it's a tremendous amount of waste of money right there. If we're widening the road, basically we're going to take the two edges of the road, cut them down to where there's a stable subbase, put some drainage aggregate in the bottom of the trench, and then either put wrap or stone on top. What we do then is we would recycle from the center line to the edge of that widened area, and then the materials are a combination of the old road plus the new, whether they're virgin aggregates or wrap, mixed in together. So we mix in the cross shafts across the cutting mandrel, mix all those materials together. So it's not all stone that get placed in there. As you can see here, this was widened and they added an aggregate to it. The trouble is they didn't do a good stabilization. They didn't get the strength in the base. They had a soft area they should have dug out and they didn't. And that's why all that failed, but it was before we recycled the roadway. Curb reveal. So when we're working with a borough, we need to cut out the curb lines. We don't want that 50-ton recycling machine pushing against any curb faces, scratching them up or destroying them. So we edge out along the curbs, around all the utilities, whether it's a catch basin or whether it's a valve box or a manhole, and we cut all that material out and export it away. In a situation like this, where we have a roll gutter pan, we're leaving 1.5 inch wedge there because we know there's 1.5 inch of 9.5 millimeter, which is going to be the wearing surface on top of the recycled base. So we're always looking at, well, what's the final wearing going to be on this particular roadway? Utilities, as I said, we've got to box them out. You either have a 10 or a 12-foot cutting mandrel. So what happens is the big machine will come to the edge of the cutout. We will lift the cutting mandrel, walk across the utility, sit down again, and continue recycling. And as the paver comes through this area, it'll portray all that new recycled mix in and around the utility, and then it will get compacted. Don't raise your manholes or your water valves until the recycling's completed, and that way you can raise them to the depth of the new hot mix, whether that's, as I said, a chip seal or a hot mix asphalt or any other type of wearing surface. Same case when you have a straight curb line. You can see where the oil mark is on the curb. That's where the old material used to be. And now you're going to put the recycle back in below that area and put a new wearing surface on top. Sometimes we need to put corrective aggregates in. If you've got a roadway that's all chip seals, it's all fine material, we may need to put some 57s down and mix those in with the recycle to give it more of a binder type of material back. They can be either out of the rear of a dump truck, or we could paver lathe them depending on the thickness of the material that needs to be added. Wrap material and millings can also be used, spread on the roadway. We normally compact them down before we start recycling through them. There's a same roadway after the recycling. So things to consider in a QC/QA plan. All meters and computers should be calibrated. You should be able to walk up and see what we're putting into the mixes. Recycling additive, check the specifications, check the compliance. Recycled mat smoothness. Density and compaction, very important. CIR gradation, the moisture content before the overlay. Need to be down around 2.5% before you start putting that wearing surface on. Check the depth of recycled material. The mix design, okay? We already got their samples from the wrap from the core samples in the field, determine the gradation and the binder content, select the amount and gradation. You know, there might be some additional asphalt within those mixes, especially if there's a lot of chip seals that we can use. The residual asphalt properties can help in the mix design and cut down on the amount of emulsions that need to be added in the mix. Select the type and grade of recycling additive, test trial mixes, core properties, final cure properties, establish the job mix formula, and follow the PennDOT CIR mix design. And there's a typical cold in place mix design. If we look down in the green areas, those are the actual, projected, what we need. If you look further down there, you'll see under the gallons and tons, this particular design is calling for 1.54 gallons per square yard at a depth of, I think it's 4 inches. I can't quite see that. But anyway, it's a 10-foot cutting mandrel. So everything is on there for the contractor to be able to look at, or the inspector, and make sure that everybody's in compliance with what they should be. Gradation, as I said, about a 2-inch minus is what we're shooting for. These machines, these down-cut milling machines, aren't crushing machines. So if you've got an oversized piece of rock in there, it's not going to crush it. It's not going to crush it to 2 inches minus. It's going to stay that size in the mix. They may have to be expelled. It may be someone has to pick that out of the mix. And that does happen sometimes. Our roadways weren't built 5 miles long. They were built a half a mile here and a half a mile there. And we filled it in between at different times in the road's life. So we don't know, even though we core it, exactly what's in that roadway. So be prepared. Selection of additives. Well, the asphalt emulsions that we use a cationic. We've talked about that this morning in several of the presentations. We use a CSS1H, which is a cationic slow set emulsion. Rejuvenating agents, we don't really get involved with. Foamed asphalt, that's a whole different sphere. It's used, hasn't been really used a lot in Pennsylvania, but I know in New Jersey they have experimented on a few projects. But you need a whole different system. It's where you're taking a hot AC and you're adding very cold water, you're making an expanded asphalt, and that is what is dispersed into your materials. So we use a dual additive. So we're using Portland cement in a lot of our mixes. We're starting to educate people, townships, and they're starting to use this. It's about a 1%. So 1% is about 5 pounds per square yard. That is placed on the asphalt ahead of the recycling train. The recycling train will pick up that Portland cement along with the desired depth that we're recycling. They're all mixed together with emulsified asphalt in the cutting mandrel, placed directly into the paver and struck off. Well, what does that do for us? The Portland cement acts in several ways. So what it does is it becomes a slurry mix, so it's filling some air voids. It's a catalyst. We haven't got to wait. Normally a cold in place recycle road, you're going to sit there and wait for 2 weeks for it to cure out. You're going to allow traffic to run on it, but it still takes that much time for the moisture, because an emulsified asphalt is about 65% asphalt cement, about 35% water. We need that water to get out of that mat before we overlay it and lock the water in place. So what the cement does is it chemically cures the road out. So within 3 days, that moisture's gone. That small amount of Portland cement has taken that out of the mix. It also makes it a stronger mix. So you could say that our recycle mix is at 4 inches compacted, has about a 0.4 structural coefficient. You want to put the Portland cement down with an automated machine. These machines are all calibrated. And you can see the small amount of cement that is laid on the roadway. One thing you don't want to do, although that's very thin laid on top, 5 pounds a square yard, you do not want any of the public driving through there with their car. That is so light it will get airborne. All right, and you'll have a dust cloud, a fog cloud there, and the car will be covered in cement. So we have to make sure that our traffic control does not allow anybody to drive into that dry product. Here you can see very close proximity from the recycle train, that tanker behind, and the actual applicator for the cement. They're in close proximity, giving the public less chance of driving into that material. And as I talked about earlier, I talked about the cure. Well, here's a site. We cut this out purposely. So within the first day, that top 2 inches of a recycled base has cured out. But it's that bottom 3 inches that we need to get the moisture out of. We need to get that dried out, and that's why we use the Portland cement. It drives that moisture out within 3 days. So single unit train, that's what we call our recycling units in Pennsylvania. There are multi-unit trains which are used in the West a lot, where they've got roads that they do 20 miles roadways, and they have crushing machines built into the operation. They have dual shaft pug mills, and they have belt scales. But to put one of those on one of our rural roads in Pennsylvania, it'd probably just take about the start to the finish of the rural road. That's how long those trains are. They're huge. So anyway, we're going to proportioning of the recycled agent is based on the volumetric depth and width of cut. Remember I said there's 10 and 12-foot cuts that we can do. The amount of liquid is dispersed into the mix and is based off the PennDOT mix design. Every project has to have a PennDOT mix design. It's as I said earlier, down-cutting milling head. It sizes the material, and the forward speed of the machine is going to determine the size, particle size that's in that mix. Materials are mixed in the milling head chamber. We'll have a look at that in a minute. And mixed materials are placed directly into a paver via a conveyor system or picked up by a windrow elevator and placed directly into the paver. So single unit, this is an RX 800, cold in place recycling. This one here, the milling machine, the white machine up front there, is actually mixing it. There's no conveyor. It's laying it in a windrow right behind the machine. And the paver is hooked to a windrow elevator, which is the yellow section. That picks up the windrow, places it directly into the paver, and is struck off to whatever the desired depth and scope is behind the paver. The working type of machine, still a down-cut machine, is onto two scales, so it'll have a first stage conveyor onto a second stage conveyor right into the paver. And the same with the single unit RX 700, which is a road tech machine. Same principle, asphalt tanker in front. The asphalt tanker is offloaded into the metering device on the front of the milling machine, and then that transfers the asphalt at the prescribed amount per square yard into the milling chamber, mixes it in there with the Portland cement and the road materials, and then directly into a paver where it's struck off. There's another shot of that RX 700. So you have an additive control system. So the inspector, this is down at ground height, the inspector can come over, take a look at that dial there. He can see how much asphalt is going in, how many gallons were used that day, how many lineal feet that machine has driven over, and he can get all his information he needs right from that computer. The other computer is basically for the cross slopes and different elevations and things like that. The milling machine has sensors on it, those yellow boxes. They're no contact sensors. There's 3 of them, one there, one on the cutting mandrel, which is directly behind it, and one on the other side of the cutting mandrel. So we have a nice cut, a nice plane there. The pavers themselves have no contact skis. You can see that there's sonics on the front and the back of that, also giving us a nice level plane, which gives us a better ride. Another shot of that, the material going into the paver. One of the other times that we would probably have to close the driving lane down for a short period of time is when that paver hopper has encountered a lot of undulation in the road, where we're trying to cut that plane out and the hopper gets full of material. We need to bring a truck alongside, turn off the asphalt supply, swing the conveyor over, offload excess material while the whole machine is still moving down the road, including the paver. And when the paver becomes manageable again, we turn the asphalt back on, swing the conveyor over, and the material goes back into the hopper of the paver. The truck drives off and the lane is reopened. So there could be another time during the day where we have to shut the road for just a few moments. Just a shot down the road of looking at the recycling process, the corrugation and that in the other lane, and there's that nice mat, fully recycled. Excess material removal, sometimes where we have a wide radius on a roadway, we may have to do some dry milling to alleviate an area where we can put recycled material in. So we'll offload material that way, and that'll get exported from the site. Steel vibratory roller, 12 plus tons. They will work directly with the nuclear gauge operator to get us to our density and compaction effort that we need on the project. And there we have that 25-ton pneumatic tired roller. And that's normally something that takes place at least 4 to 6 hours after the recycling and the initial compaction by the steel drum rollers. That will come in. We don't want that in too early, otherwise we're going to leave ourselves a lot of like little ruts across the road. So he needs to come in when that roadway has been fully compacted, and that's going to find out if we've got any bridging areas or anything like that. Another shot, the nuclear gauge operators there working with the steel drum rollers, making sure we have our density. Not that we want a road at 3.5% cross slope, but basically we're trying to make sure that we correct our cross slopes. Normally PennDOT calls for 2. I like to see a 3%. I like to see that water run off the edges, run off the road into the gutter lines and away from the project site. We'll follow it. Air temperature, 45 degrees and rising. I'd like to see it at 50 degrees and rising. No rain or mist. A day to day, we should not be recycling. We don't need any extra moisture in the mix. And when we're finished, when it's recycled, finished, the pneumatic tired roller's finished, we place a prime coat. So over the years, we've been trying to make our process better. We've added the cement, which makes a stronger mix, and a mix that cures the mat out faster. We've also added this prime coat. So every single road we do now gets a prime coat placed on top. A prime coat, it's a CSS 1H, so it's the same asphalt we're using in the mixing, but we've cut it 50% with water. And that is sprayed on the water. It takes about 20 minutes to dry. And there it is, completed, and it makes that road just better. It helps us with waterproofing until either the pavement preservation technique is placed on top or a hot mix asphalt is placed on top. And there's old roads. So what types? Rural roads, we recycle those all the time. And sometimes we get into an urban area. You can see on the left of that photograph is an older part of town, and on the right is the newer part of town. But they only bothered to take care of the first. It looks like they put new curbs in over there and put down some new asphalt, but we came in later and corrected everything and made the whole road recycled and look good. Industrial road. You know, years ago, they used to say, oh, you can't recycle a road if it's got any more than 200 ADT a day. That's ridiculous. So today, we don't really care about the amount of traffic or how much traffic there is in the initial stages. So when we turn this back over to traffic for that first half hour to an hour, it's the speed of the traffic that does the damage, not the weight of the traffic and not the amount of traffic. It's the speed. It's almost like a scrubber. You're doing a scrub on top of the road with the tire speeds going around. So the cement and the prime coat help with that also. Heavy highway. This is old US 22 between SR 419, and SR 501 in Berks County. Very heavy. There's an industrial park there, all those new container buildings that have been set up, and the traffic flow is immense. And this was reconstructed a couple of years ago. Industrial parkways, we do it all the time. Wearing surface application. Hot mix asphalt. Hey, if we could do all roads without that center joint, it'd be great, wouldn't it? So full width paving if you can. And if not, then you do 2 lanes. Ultra thin hot mix asphalt. And we know, Terry talked about how thick that ultra thin is. There's a quarter. That's about how thick that material is. Chips. I'm sorry, go ahead.
Back one.
Back one, all right. That one?
Can you put my name on the bottom of that one?
Actually, it's mine, it's not yours.
Oh, I beg you.
Oh, I beg to do it. I think you stole that from me last time you lived in Pennsylvania. All right, moving on. That's all right. It's all good, right? So chip seals and microsurfacing or cape seals. And the last one for recycling is, here's my pavement curve, all right? So we cold in place recycling down at that poor or very poor area, and let's pump it up to the excellent area after it's recycled and overlaid. Remember this, just like the guys were saying this morning, if at year 5 or 6 we look at that pavement, we see, it's starting to oxidize. Let's face it, hot mix asphalts today last about 8 years, all right? Years ago, they lasted 12 years. They don't anymore. We've got more wrap in them. They're stiffer mixes. They don't last that long. But if we put a pavement preservation technique at year 6 or 7, yes, the index falls. But if we hit it again at year 15, it falls again, but we're stretching it out. And then here at year 20, we stretch it out again with another pavement. We keep taking it out. So instead of having a pavement that lasts you 12 years, we now have a pavement that's going to take you out 25 plus years. If you use those pavement techniques we talked about this morning, and you keep extending the life of the pavement out. Yes, the index falls. Sooner or later, you will need to reconstruct it or do whatever, cold in place or whatever else. But that's a way of continuing to keep a good pavement good. And I agree with those guys this morning. We have to protect the good pavement, but also once in a while try to attack the worst in our municipalities or in our state highways. Okay, that should be recycling finished. All right, now we're going to hit full depth reclamation. Oh, sorry, go ahead.
Actually, 2 questions.
Yep.
First, going back to the curing,
Yep.
you brought up that adding Portland cement, we could go away from the 2 weeks.
Yes, you can.
So the question is by our construction standards,
Mm-hmm.
as curing for emulsified asphalt stabilizing agent as being the 2 weeks,
Right.
curing for foamed asphalt stabilizing agent is do the testing, make sure you're down below the percentage.
Right.
Is that what the Portland cement does?
Well, the Portland cement chemically cures the mat out, okay? So we still have to go to the PennDOT spec, okay? Which is 2 weeks. But the roadway's cured out within 3 to 4 days using Portland cement. Lots of the municipalities will opt for having cement because they know they can pave it sooner, okay? But according to PennDOT, we've got to wait. Now, we're working with PennDOT all the time, as Rex was saying earlier, and maybe that will get changed if you use Portland cement in the mix. The first road that PennDOT's going to do using Portland cement will be this year on 176, the Morgantown Expressway, out of Reading over to the Turnpike. We'll have to see. That's going to get the percentage, the 1% Portland cement added in the mix. So let's see. Obviously, there's going to be inspections and there's going to be people there testing the materials. Let's see what that performs and how it performs. And then we can talk to PennDOT about, maybe shortening that lifetime. But if it's just emulsion, got to be the 2 weeks, absolutely. It's going to take that long for that moisture to get out of the mat. But that's why I like to see this chemical cure rather than a temperature cure.
Okay.
All right, did I answer your question?
That answered the first one.
Oh, okay.
The second question is, you said that after the application was done, or after the process was done, you were putting down a prime coat,
Correct.
a dilution of 50%.
It's diluted with water 50%, yeah.
My question is, are we getting our prime coat in as whatever it would be, whatever its residual rate is? Are we diluting it again, or is that just in reference to it's normally coming in at a 50% residual rate?
It's coming in at a 50% residual, yeah. We technically, we have only just started doing this about 2 years now. And we experimented, and now we've picked it up more. That project,
Very painful project.
yeah, well, we're experimenting. We're trying to make, see what's wrong with right now is that we need the industrial people who are making the equipment, we need the agencies such as PennDOT, we need the contractors, and we need the people who are building the asphalt emulsions to get together and to make a better product. We're trying to work with all of these systems to get better.
I'm asking these questions coming as a material representative, trying to learn more.
Yep.
Do exactly what you're saying.
Right.
I'm not casting stones.
No. I don't think you are. I don't think you are. I'm just saying it would be great if all four could get together and say, hey, look, let's build this better. It's the old thing, the better mousetrap, right? Let's build it, right?
Let's go.
Right, so that's what we're trying to do as a company. We're trying to build it better.
Yep.
Thank you, sir. Anybody else? So we're going to go on to full depth. Yes, I'm sorry.
During queuing time, would you let traffic drive?
Traffic's going to drive on the mat, probably within 2 hours of that mat being laid, whether you have the Portland cement in there or not. The traffic's on it. It's a top-down cure. That top is curing 2 inches at least, okay? 2 inches at least, and we're going to allow traffic to run on it. We'll put a prime coat down, but traffic can run on it right away.
And second question is, the train is so long, so in a curved area, like a lot of sloping area, how would you handle it?
They keep building these cul-de-sacs. We hate cul-de-sacs. We can't get around them. So we've got to go in and actually mill them out and then process the material and then truck it back into the cul-de-sac and dump it in a truck and try to go around the radius. You know, it is tough to do curve. Now, a natural curve in a roadway, no problem. But a cul-de-sac, they're issues we have, yes.
How about in slope area? High slope, like a big...
Oh, we can go up anything. Yeah, we don't mind. We'll go up. What you don't want to do is come down, because it's a down cut machine, and if that milling head comes out of the cut, that machine's running this way and it grabs a hold of the road, it will go from 22 feet to 40 miles an hour like that. Snap your fingers. I've been there twice when it's happened. You do not want to recycle downhill on a steep hill. Recycle up. Okay? We good? Look, you got a cone. All right. Anybody else? Yes, Scott.
I got a whole box of those. You gotta give them out when they ask questions. I can't take them back.
Well, I play soccer, so it's no good me throwing it. I can kick it to somebody, but I can't throw it. All right? Okay. All right. Okay, let's go on with full depth. Okay, so when the roadway is completely destroyed, we're going to think about full depth reclamation. And there's 3 basic types. All right? There's dry pulverization, where you're just going to take the roadway and you're going to mill it all up with a pulverizer. You can add aggregates to it, and you're going to build that as basically as a base to build your roadway up onto. Bituminous, well, you're going to add an emulsified asphalt or a foamed or expanded asphalt, and we've hit on that a little bit today about the hot ACs, or an engineered emulsion, which is engineered specifically for one roadway, and that is it. You don't use that on the next road, it's just specific. Chemical stabilization, which is what we do. You can use Portland cement, lime, fly ash, calcium chloride. Fly ash. Type C fly ash is self-cementing, almost like Portland cement. If you can get a hold of that, it's great material to use. But type F fly ash is readily available. Not many people use it. Calcium chloride, boy, that material rots your equipment away. We very seldom use calcium chloride. Okay, full depth. So you're going to dry pulverize the roadway, all right? You're going to grade and remove the excess material. So you don't want to be laying product. This is a two-pass process. It's not one. If anyone comes to you and say, hey, look, we're going to lay cement on top of the road, and we're going to pulverize it and mix everything together, grade it and compact it, and we're going to be done. No, it's a 2-stage. You're going to go in, you're going to pulverize the road first, completely. You're going to grade off any excess material you don't need. So you're going to have roughly the shape of the road, the cross slope, or whatever you need. You're going to have that. You're going to take away that excess material and export it. If you mix it all together at one time, you're going to be throwing away product that you just put into that mix. So one pass is not the way to reclaim a road. It's a 2-pass operation. So you grade everything, get rid of the excess material, compact it, add your chemical, all right? So you would add all your bituminous or whatever, and then you're going to regrade and compact again, and then you're going to come in and you're going to hydrate, make sure everything's hydrated before you do a final grade and compaction. The machines, they're bidirectional, they're four-wheel drive. In this case, it's a Wirtgen. The cutting mandrel, which is where that recon sticker is on the back, that is an expandable chamber. The deeper you go, the more that expands, and so that excess material in depth you're digging is in that mixing chamber mixing. If that chamber didn't expand, it would become too full and something would stall on the machine. Compaction. That's not a sheep's foot roller, that's a pad foot roller. It's important. Pad foot roller is a mainstay in the full depth reclamation. Pneumatic tired roller, the 25 ton, again, can be used in combination with other rollers. And a steel drum vibratory roller, either dual or a single in this case, essential also. Because it's full depth and because we're going down maybe 10 to 12 inches, we need to make sure the utilities, when we're working in an urban area, are deep enough. A lot of times, your utility companies drill right through the curb for the services to the house. And here we come down the road, and we rip them all out. You've got to make sure that one right there is right under the curb. You know, they've got to be at the correct depth. And the one where my foot is in the photograph, that's just about 3 inches under. You know, that's a conduit with a cable in it, and it's 3 inches under the blacktop. Make sure that I know you do a one call, but most of the time it's marked a foot or so away from where it actually is. And, you know, normally we find them first with a cutting mandrel like that, and we cut into it. Mixed design. Okay, in this case, it's a GTA one. So there at the top there, we have the core samples. Now, when I core a roadway, I want to see a roadway cored right shoulder, center line, left shoulder. I don't want all the cores down the middle of the road. I want to know what's on the shoulders of the road. If we're going to be cutting the same depth there as we are on the crown, and a lot of times in our rural roads, the crown, the carts used to go down the center of the road, so the crown of the road is where all the material is, and at the edges we have basically nothing. Well, I'd like to see more on the edges of the road than the center of the road, but in this case, it looks like we've got about 4 there from the center. So they're telling us the depth of the asphalt. There's no aggregate, so the asphalt's right on top of dirt. Okay, and it's a silty, sandy dirt. They're going to take that, they're going to make certain plugs in the lab. And don't forget, a lab is a controlled area, all right? It's controlled. So what they produce in the lab may not be exactly what you have out in the field. The roadway changes, all right? So if they come back and they say, and I'll go to the next slide, right here, they say at the top there, they're saying, okay, we've got 4%, 6%, and 8% Portland cement. And there we have our 7-day compressive strengths, which is what PennDOT wants. But then over to the right there, we have the average compressive strength. See, 273. All right. Then we've got 328, but we've got 510. 510 in a lab is going to produce about 600 pounds per square inch in the field. That's going to crack. Absolutely going to crack. So how do we stop it from cracking? Well, we really can't. One way we can stop that is after about a week, go back with a dual spool vibratory roller and vibrate the whole mat. You will put hairline fractures in that Portland cement base, which will then expand and contract with the weather, and it won't crack the road. If you don't do that, you will have block cracks. They will come about. It's simple fact. It gets too hard. So we have to be careful when we're doing a mixed design in a lab to what we produce out in the field. And you'll see down at the bottom there, you have Highland Road, I think it says. But you have CIR depth of 8 inches, and the maximum, or the application rate's 33 pounds per square yard of Portland cement at that 8-inch depth. So when you're doing just the rubberization of the roadway, you could bring in extra aggregate, place them, grade them, or paver-lay them, and then you would mix all those materials together and it become a drainage base for whatever you're building on top. I talk with my hands, so look out. Here's those roads again. All right, that would be a great candidate for full depth reclamation, but I doubt the municipality will ever do anything with that road. And the same with these roads, great candidates for full depth reclamation. Bituminous, so you're going to go in this picture here, we've already pulverized the roadway, we're now going through, you'll see that there's a distributor hooked to the reclaimer, and that distributor is putting in the quantity of bituminous material that the mix design called for and mixing it in. Now, one of these roadways, it had such bad shoulder areas, and you can see here how that cross-section is leaning from the crown out to the shoulder. They wanted to add extra aggregates. So here we see the aggregates on the right. On the left is the first pass of the reclaimer, mixing those aggregates in with the natural soils and the natural road materials that were there, and mixing those together and striking them off. The graders then regrading everything, getting everything graded. You can see the height they had to raise the road there by the shoulder there. You can see how high that is, a couple of feet. And then, as I said, you're going to go through again, add the additive, mix it all together, do your grading, get your grading done and your fine grading, and compact the roadway, as we see here, a solid, nice looking roadway that's raised up several feet. And then a hot mix asphalt was placed on top, and that's the kind of road we produced. Now, chemical stabilization. We ran through the chemicals. So, hey, here we go again. PennDOT. This was probably 25 years ago. The interstate was reclaimed. From I-78, I-81, from that intersection, north to the Schuylkill County, Lebanon County border. I-81, all the slabs had shifted. When you came down off the mountain from Schuylkill County down into Lebanon County, all you heard was thud, 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 thud at every joint along that roadway. So the concrete was removed, rubberized, whatever. And then we came in and traffic was sent. It was an Alan Myers project, but E.J. Brenneman, who I worked for at that time, was doing the full depth reclamation. You can see we sent traffic north and south in the southbound lanes, and we went through. And you can see this is what was under those slabs, so no wonder they were moving around. That marly muck you see there had to be stabilized. Well, they came up with a solution where they used a type F fly ash, which is not self-cementing, along with lime, and they created a pozzolanic effect with the soils, and that's how that roadway is built today, underneath the new concrete that was placed on top. That gentleman there is just doing a backscatter with his nuclear gauge, finding out the moisture content. He had to control the moisture on the project. Here, that top left-hand photo is the fly ash. It's black, you know, it's out of a power plant. So that's the color, and then the lime was placed directly on top of the fly ash, and then the combination, they were both mixed in together, and they were mixed with the reclaimer. Water was added. We had to keep a certain moisture content, and Alan Myers did the grading behind and the compaction. One thing you want to do when you're using chemicals, especially if you're using quicklime, make sure you hydrate all of the lime. If you don't and you bury the lime and moisture gets to it, you'll have a volcano erupt in the middle of the pavement. And you don't want that to happen when you've got the aggregate on and you're putting blacktop on. Hydrate everything that you have there. Make sure that you've hydrated it. This is the road over by Westchester University. You can see the condition. It's poor. It's holding water. The drainage is not effective at the sides of the road. I don't believe the water could ever get off the road. Another shot of that. So here you go, the dry pulverization taking place. So pulverize everything, grade it, get it to where you want it to be shape-wise, and then add your chemicals. You can see just down on the bottom left there. Add your chemicals to the surface of the road, and then go back in with a water truck, hydrate and mix everything together, compact, as they're seeing here with a pad foot roller behind. And here we go again, coming down past the tennis courts here. We're hydrating all the chemicals into the mix. That there, somebody's going to say, well, how come that material between the two back wheels is more like an aggregate. Well, if you look to the left there, you see that yellow mark, that red mark? That's telling us there's a manhole right there, and the milling head has come up to go over the manhole, and then that will get graded in, and it'll look like the rest of the roadway. So after we've done all the mixing, we're going to go in, we're going to fine grade. As you can see here, you can see the hard pan already formed. We're going to cut against a hard surface, fine grade it, get it to where it needs to be, and then use the steel drum roller to compact the materials. And our nuclear gauge operator is going to tell us where we are compaction-wise in effort. Sometimes you're, in this case, a GTA is on the site to do some mixed design testing on site. And hydrate that road. Spray that road down. Get it wet. It's not going to move around now. The cement's in there. It's all mixed in. It's solid. But we need to get water down to hydrate. If you don't do that, and you have any product in there that's not hydrated, when you put your overlay on, and then in the wintertime when the water table comes up, you'll find that your road will become checkered. It'll have white and gray areas bleeding up through the asphalt. And that doesn't look like a nice new blacktop roadway. So hydrate everything. Make sure your product is hydrated. Very important. And there's the finished product. And if we're working in an urban area, make sure that you've got room to get around these pretty looking mailboxes that these people have in these $1 million homes. Make sure that you have your curb reveal, do your grading, all right? And when you get a clay that's like that, which is very plastic, all right? That's the kind you can ball in your hand, and when you open your hand, it's still a ball. It's not breaking away. You got to make sure your chemicals are well established in the mix. Your grading, here's your cul-de-sac, sir. Here's your cul-de-sac. It's very difficult to do a cul-de-sac, all right? Make sure the grade's right, it's compacted nice. And there's our cul-de-sac after the overlay's on with no water holes or puddles, and it all drains well. And before I close, that there is what you'd call a mucky mess, okay? Within 4 hours, we can take that. Now, if you look in the top left-hand corner, see the red silt fence up there? Can you see that? I just want to make sure you don't think I'm pulling your leg here. That's 4 hours later. There's that silt fence up there on the hill. That's how quick a chemical will change the conditions of that road. Where they couldn't get any material in to build homes, now they can get material in. All right, I'm just about done. There we go. All right, sorry, thank you.